In question 1, we need to write down the inequality shown on the number line. We can see that if we are on the right side of -1, it's an empty circle, so it's a strict inequality. So the answer is that x is greater than -1. In part B, we need to illustrate the inequality -3 less than or equal to y less than 4 on the number line given. So we've got an inclusive inequality at -3, which should appear with a full circle, and then a strict inequality at 4, which should appear with an empty circle, and therefore our answer should look something like this. In question 2, we need to find the highest common factor of 60 and 84. One way to do this is to start by splitting decomposing 60 and 84 into prime numbers. So 60 divided by 2 is 30, 30 divided by 2 is 15, 15 divided by 3 is 5, and 5 divided by 5 is 1. So I keep doing this until I reach 1. I will repeat this for 84. So we start by dividing by 2, we get 42, by 2 we get 21, by 3 we get 7, and by 7 we get 1. These are the prime factors of 60 and the prime factors of 84, and we need to pick out the common. So we've got the 2 with the 2, the 2 with the 2, and the 3 with the 3, and therefore the highest common factor will be the product of these three prime factors. So it's going to be 2 times 2 times 3, which is 12. In B, we're asked to find the lowest common multiple of 24 and 40. And now we'll put 24 and 40 next to each other. And I will keep dividing by prime numbers until I make both of them end at 1, 1. So I start by dividing by 2. Both of them are divisible by 2. So I get 12 and 20. Again by 2, I get 6 and 10. Once more by 2, I get 3 and 5. Now we'll divide by 3. 3 divided by 3 is 1. 5 cannot be divided by 3, so it stays as a 5. And now we'll divide by 5. Now this has already reached 1. Now this will reach 1. And therefore the LCM is 2 times 2 times 2 times 3 times 5, which gives an answer of 120. This is the LCM of 24 and 40. In question 3, it's a travel graph. We've got the distance on the vertical and the time of the day on the horizontal. We are told to work out the speed in the first 15 minutes of the journey. During those 15 minutes, Sam has covered a distance of 20 kilometers, so we start by noting that speed is distance over time, and the distance is 20 kilometers, and the time is 15 over 60 over an hour, because I need to get an answer in kilometers per hour, and this turns out to be 80 kilometers per hour. In part B, we are told that at 10:15 Sam stops for 10 minutes and then drives for 20 minutes at the speed of 75 kilometers per hour, and we need to complete the travel graph. So I will start by drawing a horizontal line for 10 minutes. This is the duration of time for which Sam stopped, so between 10:15 and 10:25. And then we know that he was traveling 75 kilometers per hour, so 75 kilometers in 60 minutes, and we would like to find how many kilometers he covered in 20 minutes. So we can easily use cross multiplication to say that x is 75 times 20 over 60, which means we get an answer of 25 kilometers. So going back to our distance time graph, we know that he covered 25 kilometers up to 10:45, so in those 20 minutes he covered 25 kilometers. In question 4, we need to complete the table of values. Here we've got some y values and we need to find the rest of them. We can use a calculator for this. We get a value of 5, of 1, of 2, and of 10 here. So this is the first part, and then we want to plot the points and join them with a smooth curve. So we have plotted the points, we join them with a smooth curve as shown here, and this is the graph of y is x squared minus 2x plus 2, And then in part C, we need to use the graph to solve the equation x squared minus 2x plus 2 is 4. So this simply means that we need to draw the line y equals to 4 and identify the x values of the points of intersection. So we draw the line here. We go down at the point of intersection just to identify the values for x. And we see that one value here is at minus 0.7 and the other is at 2.7 to 2.8. So we can say that x is minus 0.7 or x is 2.7. Do bear in mind that the examiner here will follow through from your graph and accept a range of values because everyone has drawn their curve in a slightly different way. In question 5, we're given a right angle triangle and then it is used twice to form this shape and we need to work out the perimeter of the shaded shape. I will start by calling the hypotenuse in the original right angle triangle h, and I will use Pythagoras theorem to find h. So 8 squared plus 10 squared is h squared. So 164 is h squared, which means that the root of 164 is h. So going to the diagram here, we know that this here is the hypotenuse, which is 164. Now, this part here is 10 millimeters, and this part here is the hypotenuse again, root 164, which means that the remaining part, the small part here, is root of 164 minus 10. Therefore, the perimeter, if I start from the bottom left-hand side, it's 8 plus 8 plus root of 164 plus root of 164 minus 10 plus 10. So it's going to be 8, we said, plus 8 plus root of 164 plus root of 164 minus 10 plus 10. And this gives an answer of 41.6 centimeters. In question 6, we need to work out the length of BC. Now, 12 centimeters is the adjacent to 56 and BC is the opposite. They are connected through tan. So tan of 56 is equal to BC over 12. We cross multiply, so 12 tan 56 is equal to BC, which leads to BC being 17.8 centimeters. In B, to work out the size of the angle X here, we notice that the 15 is the adjacent, the 18 is the hypotenuse. They are connected through cosine. So cos of X is 15 over 18. So X is shift cos of 15 over 18. And this gives an answer of 33.6 degrees. In question 7, we've got the density of liquid A and liquid B, and we are mixing 80 cubic centimeters of A with 40 cubic centimeters of B to get liquid C. We need to work out the density of liquid C. We start by reminding ourselves that the density is simply mass over volume, and I can draw up a table for A, B, and C. We have mass, then it's volume, and then it's the density. And I will try to put all the information I've been given on this table just to see exactly on what's happening. We know that we've got 80 cubic centimeters of A, 40 of B, and therefore a total of 124 C. We know the density for A is 1.8 grams per cubic centimeter, and for B is 1.2 grams per cubic centimeter. Now going back to the formula here, density times volume is the mass. So if I multiply density with volume, I will be getting the masses of A and B. So we can say here that for A, it's 80 times 1.8, which gives an answer of 144 grams. And for B, it's 40 times 1.2, which is 48 grams. So 144 plus 48, that means that the mass of C is 192 grams. and therefore we have just obtained the mass and the volume of C. So I could simply say that the density of C will be the mass, 192 grams, over the volume, 120 cubic centimeter, which works out to be 1.6 grams per cubic centimeter. In question 8, we've got the grouped frequency table here for the times taken by 50 people to solve a puzzle, and Brian drew a cumulative frequency table, and we need to write down one thing that is wrong with the cumulative frequency. Now, if you notice at the classes, the groups here, they still go from 0 to 10, 10 to 20, and so on. Well, we know that if it's a cumulative frequency, then all the starting points should have been 0, so that at the end you include all 50 of them, so that should be between 0 and 60. So the mistake here is that the starting point for all classes should have been 0. In 9, we have the box plot showing information about the length of time in minutes, and we need to work out the interquartile range. Well, we know that from the box plot we've got Q1 here, Q2, and Q3, and the interquartile range is Q3 minus Q1, the upper quartile minus the lower quartile, which is 188 minus 50, which gives an answer of 138. In B, we are told that Becky says 50% of the people waited for at least 2 hours, and we need to explain whether Becky is correct. Well, the 2 hours, the 120 minutes is exactly the median, so she is right because 50% of the people waited for more than 2 hours and 50% for less than 2 hours. So we can simply say that since the median is 2 hours, then Becky is correct. We are then given the length of time people waited on Tuesday. So we've got the shortest time, the longest time, the quartiles, the median, and Becky was asked to compare the times on Monday and Tuesday, and she wrote that people had to wait longer on Tuesday than on Monday. We will need to give one reason why Becky may be wrong. We could base our explanation on the fact that the median for Tuesday is 100, and for Monday we found this to be 120. So on average, people were waiting longer on Monday. So we can simply say that Becky is wrong because the median for Tuesday, 100 minutes, was less than the median for Monday, which was 120 minutes. In question 10, Louise has invested X pounds in better investments for 3 years, and Sadiq invests X pounds in County Bank for 3 years. At the end of the 3 years, the value of Louise's investment is 344,605, and we need to work out the value of Sadiq's investment at the end of the 3 years. So we start with Louise because we need to find X first. We know that if Louise had invested X pounds, this was attracting interest at 2.5% per annum compound interest. So the multiplying factor is 1.025 raised to the power of 3 because this was happening for 3 years. And this gave an answer of 344,605 pounds. So X is 344,605 over 1.025 to the power of 3, which gives an answer of 320,000. This is the original investment both for Louise and Sadiq. So for Sadiq, we're going to do 320,000 times 1.02 to the power of 2, which is the 2% per annum for the first 2 years, times 1.035, which is the 3.5% for the extra year, and this gives an answer of 344,580 and 48 pence. In 11, we start off with a sketch of the line L. We know it passes through the points P and Q, and we are told that the ratio of PQ to QR is 2 to 3. So that means that if this is 2, then this is 3, and we need to find the coordinates of point R. Well, we know that to go from P to Q, I will be going 6 to the right, 3 up, and therefore I can use the ratio of 2 to 3 to say that to go from Q to R, I will be using this ratio. So the horizontal movement here will be 6 times 1.5 because QR is 1.5 times PQ. So this will be 6 times 3 over 2, which is 9. And similarly, the vertical rise will be 3 times 3 over 2. So think of 3 over 2 as your scale factor. So this is 9 over 2. So if R had coordinates x, y, this means that x will be simply 9 and y will be 3 plus 9 over 2, which works out to be 15 over 2. It's because we were at 3 and we rose by another 9 over 2. So the x coordinate will be 9 and the y coordinate will be 15 over 2. For part B, we need to find the equation of the line perpendicular 12 passing through point Q. So if we go back to the line here, this is the line. We can see that the gradient is given by rise over run. So the gradient will be 3 over 6, which simplifies to a half. Now to find the gradient of the perpendicular, we know that we take the gradient, we flip it, and we change the sign. So the gradient is -2. It's a straight line that passes through the point Q, so it's cutting the y-axis at 3. Therefore, its y-intercept C is 3. So the equation of the straight line is y is minus 2x plus 3. In 12, we need to expand and simplify these 3 brackets here. So we start with x minus 2, and I will expand the 3x plus 2 times 2x plus 3. 3x times 2x is 6x squared, 3x times 3 is 9x, 2 times 2x is 4x, 2 times 3 is 6. So I will collect like terms after the expansion, 6x squared plus 13x plus 6, and I will be expanding once more, 6x cubed plus 13x squared plus 6x minus 12x squared minus 26x minus 12, which simplifies to 6x cubed plus x squared minus 20x minus 12. In question 13, we've got teachers and students, girls and boys. We've got 16 teachers, 120 girls and 100 boys, and we're going to be choosing a teacher, a girl, and a boy to represent the school. We need to work out the number of different ways that this can be done. So we've got 3 groups of people, the teachers, the girls, the boys, and we've got 16 teachers, 120 girls, and 100 boys. So to find the total number of different ways, multiply 16 by 120 by 100, which gives 192,000 different ways that this can be done. In question 14, we've got the cyclic quadrilateral ABCD and the tangent ST. We know that the angle here is 20 degrees, and in addition, the ratio of BAD to BCD is 3:1. We need to work out the size of SBA, and we need to be providing reasons. We start by using the ratio here. So if the angle here at A is 3x, then the angle at C is x. And we do know that 3x plus x must be 180. The reason is opposite angles of a cyclic quadrilateral add up to 180 degrees. Therefore, 4x is 180, which makes x 45. So I will actually go back to my diagram here and update with the information. So x is 45, 3x is 135 degrees. The next step is that I can find the angle here at D by using the fact that angles in a triangle add up to 180 degrees. So what we can say is that ADB is equal to 180 minus 135 plus 20, which works out to be 25 degrees. The reason being angles in a triangle add up to 180 degrees. And now that we have the 25 degrees here at D, we can see that the angle we're trying to find, the angle SBA, should be equal to 25 degrees. The reason is the alternate segment theorem, because with this chord here, the 25 degrees is equal to SBA, and therefore SBA is equal to 25 degrees. Alternate segment theorem is the reason. In 15, we need to find the length of BC in this triangle here. I'll be using the cosine rule, so BC squared is 8 squared plus 11 squared minus 2 times 8 times 11 times the cosine of 72. If we plug in everything on the calculator, we get that BC squared is 130.613. I take the square root of 130.613 and we get a value of 11.4 centimeters for the length of BC. In B, to find the area of triangle ABC, I'll be using the rule that says that the area is a half AB sine C. So it's a half times 8 times 11 times the sine of 72. Remember, the angle is always the angle that's included between the two sides, the lengths of which we are using in this formula. So plugging this on the calculator gives you an answer of 41.8 square centimeters. In 16, we need to use the iteration formula given here to find the values of x1, x2, and x3 if we start at x0 is 2. So x1 is the third root of 10 minus 2x0, which is 10 minus 2 times 2, the third root of this, which gives an answer of 1.817. I could continue in this fashion. I get x2 to be 1.853 and x3 to be 1.846. Now for part B, we are told that x1, x2, and x3 are estimates of the solution of an equation of this form. We need to find A and B. Well, if we go back to the iteration formula and we ignore the subscripts, we see that we're trying to solve x is the third root of 10 minus 2x. So if I raise to the power of 3, I get x cubed is 10 minus 2x, which simplifies to x cubed plus 2x minus 10 is 0. So comparing with what I was given, I can see that A is 2 and B is negative 10. So that's my answer. A is 2, B is negative 10. In 17, we've got a histogram of the scores of people, and we know that in a histogram, it's the area that gives me the frequency. We are told that 20% of the people got a score high enough to qualify for the second round, and we need to find this score, this qualifying score. I will start by finding the area of each bar. So for the first one, it's 5 times 0.8, which is 4. The second one is 10 times 1.6, which is 16. The third one is 10 times 2.2, which is 22. And the final one is 15 times 1.2, which is 18. This means that we've got a total of 4 plus 16 plus 22 plus 18, which is 60 people who are included in this histogram. And 20% of that, so 20 over 100 times 60 works out to be 12. So the first 12 were to qualify for the second round. Now it is certain that the 12 people are somewhere here. So I will actually draw a bar, a rectangle, that goes from x up to 40. There it is, from x up to 40. It has a height of 1.2, and we want the area of this to be 12. So we will simply do the base, which is 40 minus x, times the height of 1.2, and this should be 12. So if I expand, 48 minus 1.2x is 12. So 36 is 1.2x. If I divide by 1.2, I get that x is 30, and therefore the score needed to qualify for the second round was 30. In 18, we're given the graph of sine x between 0 and 360, and we are asked to obtain estimates for all four solutions of sine x is 0.6 for x between 0 and 720, which means that I could draw a line at y is 0.6. This is the line y is 0.6, so the intersections are those points, those values of x for which sine of x is 0.6. Now if you notice from 0 to 90 I've got three big squares, so each one of them is 30 degrees, and then each square is subdivided into 5 smaller ones, so each small square is 6 degrees. So this here is 36 and the other value is 144. So two solutions are 36 and 144, and then I use the fact that the sine graph repeats every 360 degrees. So if I add 360 degrees onto 36, I get another solution which is 396. And similarly, if I add 360 degrees onto 144, I will get the fourth and final solution of 504 degrees. In B, we are told that sine x is reflected in the x-axis, and we need to write down an equation of the reflected graph. Now, if I'm reflecting in the x-axis, it means that all the y values get multiplied by -1, so those that were in the positive y are now in the negative y and vice versa. So we're looking at the graph of y is minus sine x. In C, we're given the graph of f of x, and we are asked to draw the graph of y's f of x minus 2. Now we know that this x minus 2 is simply a translation 2 units to the right, and therefore if we take this graph here and move it 2 units to the right, we will be seeing the final transform graph, which should look something like this. In 19, we've got three spheres, A, B, and C. We have the volume of A and the volume of B. We've got the ratio of the radius, so the radius is a length essentially, so B to C is 1 to 2. And for the volume, we know that the volume of A is 125 cubic centimeters and B is 27 cubic centimeters. I need to work out the different scale factors. So the length scale factor between B and C is obviously 2. Now from A to B, to go from 125 to 27, I multiply by 27 over 125, which is 3 over 5 to the power of 3, and therefore we see that the length scale factor from A to B is times 3 over 5. We need to work out the ratio of A to C. So to go from A to C with respect to area, I take the length scale factors and I square them. So to go from A to B, it will be times 3 over 5 squared, which is 9 over 25. And then to go from B to C, it's gonna be times 2 squared, which is 4. So we could simply say that the area of A times 9 over 25 times 4 will give me the area of C. So the area of A times 36 over 25 is the area of C. So 36 times the area of A is equal to 25 times the area of C. We need to find the ratio of the area of A to the area of C. So area of A over area of C is simply 25 over 36, and therefore the ratio is 25 to 36. In 20, we are told that if it rains on a given day, the probability to rain on the next one is 0.8. If it does not rain, then it will rain the next day with a probability of 0.6. And we've got someone who says that there's a 70% chance it will rain on Monday, and we are wondering what's the probability it will rain on Wednesday. So we will approach this through a tree diagram, and we have the 3 days, so it's 3 sets of branches. Monday, Tuesday, Wednesday, it could rain or not. Starting on Monday, the forecaster says there's a 70% chance, so 0.7 for a rain, 0.3 for no rain. Now when it rains, the probability it rains again is 0.8, so the probability it doesn't rain is 0.2, and therefore when it rains, it's again gonna be 0.8 and 0.2. However, if it does not rain, on the next day, the probability it will rain is 0.6 and 0.4. Similarly here, it didn't rain, so the probability it rains on Tuesday will be 0.6, and the probability it doesn't rain is 0.4. But if it rains on Tuesday, it will rain again on Wednesday with a probability of 0.8, and it will not rain with a probability of 0.2. And then if it doesn't rain on Tuesday, it will rain on Wednesday with a probability of 0.6 and will not rain with a probability of 0.4. So these are all the possibilities. Now the question is, what is the probability it will rain on Wednesday? So it could rain if it rains on all 3 days, or we could be looking at rain, no rain, rain, or no rain, 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 or no rain, no rain, rain. So there are 4 different routes that take me to Wednesday being a rainy day. So I will be multiplying the probabilities. So 0.7 times 0.8 times 0.8 plus 0.7 times 0.2 times 0.6 plus 0.3 times 0.6 times 0.8 plus 0.3 times 0.4 times 0.6. This gives an answer of 187 over 250. You could also give this as a decimal, it's 0.748. In 21, we've got the time period capital T as 2 pi root of L over G. We are told that L is 52.0 to 3SF and T is 1.45 to 3SF, and we need to find the upper and lower bound for G. We should be using pi to be 3.142. So I will start by finding the upper and lower bounds for L and capital T. So 52.0 to 3SF means we are between 52.05 and 51.95. For capital T, it's 1.45 to 3 significant figures. So it's between 1.455 and 1.445. Now I will take the formula given. Capital T is 2 pi root of L over G, and I will start by making G the subject. So T over 2 pi is the square root of L over G. So I could square everything. T over 2 pi all squared is L over G, and therefore T squared over 4 pi squared is L over G. So GT squared is 4 pi squared L, which means that G is 4 pi squared L over capital T squared. Now to find the upper bound for G, I will make L as big as possible and T as small as possible. So it's going to be 4 times 3.142 squared times 52.05 over 1.445 squared, which gives an answer of 984.4. And for the lower value of G, the lower bound will make the L as small as possible and the T as big as possible. So it's going to be 4 times 3.142 times 51.95 over 1.455, which gives an answer of 969.0, and therefore we conclude that the upper bound is 984.4 and the lower bound is 969.0.